This is a video on neutralization reactions for the topic Chemical World for Year 9 Science. Before I dive into it, I'm just going to do a quick recap on acids and bases. So acids, if you recall, they like to give away hydrogen ions in a solution. So in other words, acids contain and they give away hydrogen ions in a solution. Okay, if you recall, an ion is a charged atom. Neutral hydrogen has one proton and one electron. On the periodic table, it's the first element. Atomic number of 1, meaning it has one proton and one electron. Okay, neutral because it's got one positive, one negative charge. Think of a seesaw. It's favorable for hydrogen to have its electron removed, so it then becomes just one proton. Okay, so from H to H plus is the notation with a superscript. That means it's the hydrogen is now charged. It's got a positive charge overall. So they're acids. Bases, on the other hand, they like to give away hydroxide ions. Hydroxide is just a name for this polyatomic ion. So polyatomic, poly means many, atomic means to do with the atom. If there's two or more atoms stuck together and you get a charged overall compound, that's a polyatomic ion. Okay. H plus on its own is not polyatomic. Okay, it's monoatomic. In this case, mono means one. But anyway, that's the name that chemists give to OH minus. So it's an oxygen and hydrogen stuck together. So bases contain and also give away hydroxide ions. Okay, it's a very simple idea by definition. Acids, just want you to have this picture in your head of acids being red. Okay, just seems to make sense. Not only to me, but for students as well. They can categorize things easier in their brains. Acids have a pH less than 7, okay? So in other words, a pH from 0 all the way to 6. Bases, I want you to think of them as blue, have a pH greater than 7. In other words, they've got a pH in the range of 8 to 14. So the minimum, the least amount of pH you can have is 0. And the most amount of pH you can have is 14. And on either end, either extremity, it gets more dangerous in terms of handling, okay? Not good for the skin, etc., etc. Okay, and a pH of 7 just means the substance is neutral. 7 indicates neutral. Okay, for example, pure water. If you go to the Alps mountains, you get pure water from there. Typically the pH is 7. Okay, so it's pure, it's neutral. It's neither acidic nor basic, and typically has a balance of hydrogen, positive hydrogen ions, and negative hydroxide ions. Okay. So that's a recap of acids and bases. Let's now get into the nitty gritty. So that being said, I suppose I'll give you this list here. I've got 4 substances, and you've got to tell me if they're acidic or basic, if they're acids or bases. Here's how you do it. Just use the definition. Acids contain hydrogen ions, H plus ions. Bases contain hydroxide, OH minus ions. So in this case, you can see HCl, H, okay, it means it's made up of H plus and Cl minus, okay, because when you crisscross, remember the rule, so you stick them together. If there's nothing, if there's 1 at the top, plus 1, minus 1, you don't bring them down. So HCl contains H plus, which means it's an acid, A for acid. HNO3, so H plus, so the valency of hydrogen is H plus, and NO3 by definition is minus, nitrate ion. Stick them together and you get HNO3. Okay, in other words, another way of think of it is, when you combine these two, they better give you something like this, HNO3. This is actually called nitric acid. It's an acid. It's got H plus, so it's an acid. The next one, KOH, potassium, K plus, okay, valency of plus 1 because it's in group 1 on the periodic table. Hydroxide's OH minus. By definition, bases contain hydroxide, so it's a base. Sticking the K and OH together, you get KOH. Next one is Ca. Apologies for the mess. CaOH2. You can see here Ca is calcium, Ca2 plus, right? Plus 2. It's in group 2, it's a metal, plus charge, and hence valency plus 2. And OH minus, okay? When you crisscross these, combine them, put them together, the 2 comes down to here. Now you've got to put brackets because OH is a compound, right? You've got to put brackets. So the whole thing with subscript 2, and the -1 doesn't come down. So that's CaOH2. OH minus, that indicates that it's a base. Calcium hydroxide is a base. Okay, so these are some common acids and bases. Let's now get into neutralization. So neutralization is quite a simple reaction. By definition, it's when, so here's the generic word equation. Acid plus base gives you salt and water. Acid has a pH less than 7. Base has a pH greater than 7. The salt that's formed is neutral, pH is 7. And the water as well, but the salt that's formed is neutral. In other words, the acid and base, they neutralize each other. They cancel out, in other words, to give something that's neutral. Hence, neutralization reaction. Now, in an exam, they will ask you to name the salt. Okay, it's not the salt that we're familiar with, table salt, sodium chloride. There's many different types of salt. And the water is, as you know, is just H2O, hopefully. So from here, it's just doing examples. Now, before I do examples, there's sort of like some rules you need to know. So salts, this is very important. This will feed into everything else we do from here. A salt, by definition, is an ionic compound. This was done a while back in class, but it's just worth knowing once again. Ionic compounds are made of metals, a metal and non-metal element. And you always write the name of the metal first, by definition. For example, sodium chloride is an ionic compound because sodium is a metal and the chloride, the chlorine, is the non-metal. And we write "ide" at the end instead of chlorine because that's just the way the convention is for naming. Okay, you replace the "ine" with "ide." That being said, when you've got things like, actually what I'll do is I'll leave that when we do examples. Let's do some examples. Okay, so let's see how this thing works. Let's do example 1, EG1. Let's suppose I've got the following reaction. Hydrochloric acid. Gotta try and fit this in. It's a long equation. Okay, the most common, I'd say, textbook example, classic example, sodium hydroxide of neutralization, right? This makes salt. Okay, suppose they give you this in an exam and they ask you to find the products. Okay, the word equation. What you do is, you know that, so you recognize that you've got an acid and a base, okay? Because hydroxide, by definition, is contained in a base. Sodium hydroxide is a base. So acid and base. Using the word equation, general word equation, you get salt and water. Step 1. Okay, that's step 1 to identify the type of reaction this is. So two products. Okay, step 2, let's now find the name of the salt. Here's how you do it. What you do is so salt by definition, metal and non-metal. Wherever you see a metal in this reaction, you write it down first. So sodium, typically it's in the base, right? Sodium goes first, the non-metal. Now, you go to the acid. So go to acid, metal, go to base. Okay, with practice, you'll get used to this. And I know students today in my lesson that literally could do this using their heads, okay, without having to write it down. So it's just a bit of practice. Let's go to the base. Let's go to the acid, apologies, for the non-metal. Hydrochloric. Now, it's not sodium hydrochloric, it's sodium chlorine with the chlorine replaced by chloride. Okay, so take that N bit and replace it with IDE for chloric. Chloric becomes chloride. So the salt is sodium chloride and you get water. They're the products. Sodium chloride is table salt. Okay, so I'm going to highlight this, it's very important. With chloric, it becomes chloride. It's a rule of thumb there. That's example 1. Let's do example 2. Let's do another one. EG2. Let's do nitric acid plus potassium oxide. Okay, step 1, identify. Okay, so everything is like a recipe for me in chemistry or in science. It's a recipe, it's a set of rules, it's a process. Okay, nitric acid is an acid, obviously. Now, potassium oxide, oxides are typically bases. Okay, even though it doesn't contain hydroxide, it contains oxygen. That's a base, and it makes a salt plus water by definition, yeah? Step 1. Step 2, let's write down the name of the salt. I'm going to do it down here. Remember, it's metal and then non-metal. Okay, metal name. The metal name is found in the base, right? That's potassium. So you write down potassium first. The non-metal is found in the acid. Now, the nitric acid becomes nitrate. Potassium nitrate. Okay, that's a salt. So the nitric, rule of thumb, nitric becomes nitrate. Okay, that's example 2. Let's do another example. Example 3. Sulfuric acid plus sodium hydroxide. Actually, you know what? Let's do calcium hydroxide. Step 1 is to identify acid, sulfuric acid. The base is calcium hydroxide because it's got hydroxide. Salt plus water. Step 1. Step 2. Let's name the salt. Okay, remember, metal. I want you to write this down every time you do it. Okay, even in an exam, it's better to get things right than to leave things blank at the end of the day, right? Doesn't matter if it takes you a while. The more you spend on a question in terms of doing things properly, the more chance of you getting it right. That's how I see it. So I'm all about annotating questions, going through steps. Metal. Now going to the base, calcium is a metal. Okay, you can use the periodic table too to help you. You don't have to memorize that calcium is a metal. Just use the periodic table. Eventually it will come naturally to you. The non-metal in the acid, sulfuric becomes sulfate. And that's it, calcium sulfate. Sulfuric becomes sulfate. Okay, just like nitric becomes nitrate. Example 3, let's do example 4. Let's do acetic acid and magnesium hydroxide. This will be the last one I do. Step 1 is to identify. That's the acid, acetic acid, and that's the base, magnesium hydroxide, because of the hydroxide, once again. That gives us a salt and water. Step 2. The name of the salt, remember, metal and non-metal. It's very hard to write on this, apologies. Metal name is in the base, magnesium. Magnesium is the metal. Non-metal, that gives us, the non-metal, you go to the acetic acid, the acid. Acetic becomes acetate. So it's magnesium acetate. The acetic becomes acetate. I'll actually do one more. Bit of a trick question. Here's what I'll do. Let's do potassium. Actually, let's do francium hydroxide plus hydrochloric acid. Okay, step 1, identify. Now, in this case, you're starting off here with the base. Hydroxide is the base, francium hydroxide. Acid is on the right, salt and water. Step 1, step 2, let's name the salt. Once again, so I'm hoping you're noticing a pattern here with the naming plus non-metal. Okay, the process is simple. The metal, go to the base. Okay, the base is first here, so be very careful in an exam. You have to eyeball this. Francium is the metal. It's in group 1. It's the most reactive alkali metal. For the non-metal, go to the acid. Hydrochloric, remember, becomes chloride. Okay. So francium chloride, remember the hydrochloric becomes chloride. And that's pretty much it. That's how you write down neutralization reactions and name salts.